Hi, my name is Matt Demeglio and I'm a tutor at the UNSW School of Computer Science. Today we're going to use stacks to solve perhaps a harder problem than we did in the last video. So the problem goes like this. We'd like to write a function called brackets match, which given a string, returns whether or not the brackets in that string match up. Okay, so what does it mean for brackets to match up? Well, let's have a look at some examples. So, first of all, clearly the non-bracket characters don't really matter. So let's ignore them. And let's first have a look at the first string, the one with hello. It is a matching string because all of the brackets are perfectly nested within each other and they all have a pair, as you can see by the coloring. Now, the second one is not a matching bracket string because the first closing parenthesis, the pink one, doesn't have a matching opening parenthesis. The third one isn't a bracket matching string because the bracket which we expect to match with the opening square bracket is in fact a closing parenthesis, so they don't match up. And the same with the opening parenthesis, we expect to match up with the closing square bracket, but they don't match. And finally, the string pi, it isn't a bracket matching string because the final opening parenthesis isn't closed. It doesn't have a matching closing parenthesis. So hopefully that kind of makes clear what exactly a bracket matching string is. So let's now think about what it really means for a string to be bracket matching and maybe try and come up with a methodology for deciding whether or not a string is a bracket matching string. So we're going to look more closely at the hello example, and like any kind of string processing, we're going to process the string from left to right. So notice that the opening parenthesis, the one highlighted in pink, is all that we've seen so far. And so at this point in time, it's perfectly plausible that this is a bracket matching string. So I'm going to represent that by showing the possible closing of the unmatched brackets up the top there. Okay. So far so good. So we're going to move through the string, and as I said, we can ignore the non-bracket characters. So the next character that we're going to stop at is the next opening parenthesis. And notice so far again, it's perfectly plausible that these brackets are matched up within the rest of the string. And that's represented by the two closing brackets I put above. Okay, so let's move to the next bracket. Now here we've reached a closing bracket, so we have to decide whether or not it matches up with an opening bracket. Now the key point to realize here is, if it does match up with an opening bracket, then it'll match up with the most recently seen opening bracket which hasn't already been matched. So in this case, that bracket is going to be this opening yellow bracket. And because this opening yellow bracket is a parenthesis and matches up with the parenthesis that we're currently at, we have a matching pair. And so we've matched them together. And notice that now the remaining unmatched brackets, well, that's just the pink opening parenthesis, and it could potentially be matched up within the rest of the string. So let's keep going. So we're now going to move to the next opening bracket. And again, it could potentially be paired up with a closing bracket somewhere later on in the string. And again with the opening square bracket. Okay, so we're now at another closing bracket, this time a closing square bracket. And if it is going to be matched up somewhere early in the string, then the one we expect it to match up with is the most recently seen unpaired opening bracket. And in this case, it is in fact a square bracket, so they do match, and we match them up, and we keep going. So we see a closing brace. So if it is going to be matched up with any opening bracket, well, that bracket is going to be the most recently seen unmatched opening bracket. And because in fact this most recently seen unmatched bracket is an opening brace, we can match them up. And finally, we do the same thing for the closing parenthesis. So what we've just done is we've kind of come up with a procedure which we could do to decide whether or not a string is matching. Essentially, we're going to move through the string, and whenever we see an opening bracket, we're going to push it onto a stack. Whenever we see a closing bracket, well, that closing bracket is going to match up with the most recently seen unmatched bracket. Now, the most recently seen unmatched bracket will always be at the top of the stack. So if we pop the element off the top of the stack and check to see whether it matches up with the bracket that we're currently at, well then, if they don't match up, then we know the string is not a bracket match string and we can return false, but otherwise we keep going and we keep doing this until we reach the end of the string. Now, of course, if we reach the end of the string and there are still unmatched brackets within the stack, then this means that we haven't matched up all of the brackets in the string, so we can also return false in this case. So let's have a look at the code and see how it works in practice with the same example. Okay, so here we have some code which implements the idea that I was just talking about. So we'll iterate through the code and see how it works on the same example that we had before. So here's our string S. It's the same string that we had before, and the first thing we're going to do is we're going to create this variable called isBalanced. So we set isBalanced to true because we're going to assume the string is balanced until proven otherwise. That is, until we reach a point where we find two brackets which we expect to match, but they don't. Yeah, balanced is just another name for saying a bracket matching string. Okay, so let's move on to the next step. We're going to create a stack, and this is the stack where we're going to put the characters. Alright, so we have this. So we have to iterate through the string from left to right. So this variable I is going to keep track of the index of where we're up to in the string. And obviously we start at index 0. Okay, so because the current character is not a null terminating character, we continue with this loop. Now, notice that the current character is in fact an opening bracket, which means that we're going to push it onto the stack. And we now move on to the next character. Again, because we haven't reached the end of the string, we will process this character. So it isn't an opening bracket. It's also not a closing bracket, which means we don't do anything with it. Remember, we said we'd ignore characters which aren't brackets. And let's move to the next one. So we have another opening bracket. So we're going to push it onto the stack. And we have another character which isn't an opening or closing bracket, so we're not going to do anything with it. And again. Okay, so here we have our first closing bracket. So it's not an opening bracket, it is a closing bracket. So now we first check to see whether the stack is empty. Now this is important because if the stack is in fact empty, then it would be a bug for us to pop off the stack, which is what we're about to do in a moment. And if you think about it, if at this point the stack is empty, then we're trying to match up this closing parenthesis with an opening parenthesis which doesn't exist, because the stack is containing all of the unmatched brackets we've seen so far. So if this closing parenthesis did have a matching opening parenthesis, it would have to be on this stack. So that's why we have this check is empty. So in this case, the stack isn't empty. So now we're going to evaluate the second part of this, well, as I suppose it is quite a complex condition. So we're going to pop the top of the stack off, and it is an opening parenthesis. And notice that it does in fact match up with the closing parenthesis that we're currently considering. So this part of the condition is in fact false. Well, okay, so it did match up, so not matching is false. And so the whole, together, because we're ORing false and false, we get false. And now we're going to AND true and false, so we get false. So all in all, this condition is false, which means that we don't do anything in this case. We've matched them up, so we don't need to return. So because they matched up, we haven't proven that the string isn't balanced, so we don't do anything in this case. And so we move on. We move to the next character in the string. And in this case, again, we haven't reached the end of the string, so we keep going with our loop. Now, this is in fact an opening bracket, so we're just going to push it onto our stack like before. And we move to the next character. It's neither an opening bracket nor a closing bracket, so we don't do anything. And we have another opening bracket, so we're going to push it onto our stack and move on to the next character. Okay, so we're now back to a closing bracket. So we haven't reached the end of the string yet. It isn't an opening bracket. It is a closing bracket. Our stack is not empty. So we're going to pop the top element off the stack, and we're going to compare it to the element we're currently at in the string. And notice that these two elements are matching, so the statement not matching is going to be false, which means that the whole statement here is going to be false, because we're ORing false and false, which means that the whole statement is going to be false, because we're ANDing true and false, which means we don't do anything in this case, and we continue. Okay, we've reached another closing bracket. This time it is a closing brace. So it's not an opening bracket, it is a closing bracket. The stack's not empty, so we're going to pop the top element off the stack, and we're going to compare it to the element that we're currently at. Notice that these two brackets do in fact match. They're both braces. So the statement matching of the two brackets is going to be true, which means not matching is going to be false. So together, when we OR false and false, we get false. And when we AND true and false, we get false. So we don't do anything in this case, and we continue. Okay, so we've reached a character which is not a bracket. So in this case, we don't do anything. Okay, we've reached a closing bracket. In this case, it's a closing parenthesis. So we notice that it's not an opening bracket. It is a closing bracket. The stack's still not empty. So we're going to pop the top element off the stack. We're going to compare it with the current element that we're looking at in the string. So these two brackets do match. They're both parentheses. So the statement not matching is false. And false ORed with false is false. And true ANDed with false is false. So we don't do anything in this case. Okay, so now we're up to the null terminating character of the string. We've reached the end of the string, which means that this condition here is going to be false. So we're going to continue. Now we recall I said we need to check whether the stack is empty at this point. This is because if the stack was not empty, then it would contain a bracket that we've previously seen, an opening bracket, which hasn't yet been paired up with a closing bracket. And if this were the case, then the string obviously wouldn't be a bracket balanced string. But in this case, we notice the stack is in fact empty, so this statement here is false, so we continue. Now we've reached the end of the function. We know for sure at this point that our string is in fact bracket balanced. Notice that our variable is balanced is still true. So we need to remember to free our stack, because when we created the stack, the create function would have called malloc at some point to allocate the memory in order to hold the data corresponding to this stack. So we call stack free, and it's freed, and now we can return is balanced. So what I suggest is perhaps work through this code with a few of the other examples I gave at the start of the video in order to see how a non-bracket balanced string leads to this function returning false.